All right. Unit 12, probability. Probability is how likely an event is to occur. It can be written as a fraction or a decimal, and in that case, between 0 and 1, or percent, between 0% and 100%. If there's no chance of it happening, impossible, the probability is 0. If it's going to happen for sure, the probability is 1. And then everything in between, unlikely, equally likely, and likely. Now, these aren't the only numbers. Obviously, if you had a 0.44, that's closer to unlikely. It's all kind of a sliding scale, where it is on the chart. But those are the benchmark numbers we use. Sample space. This is a list of all the outcomes that could occur. How do we do it? If we list them, we use these braces and separate them by columns. We can also do a tree diagram. A tree diagram is when you have something like that, or a table or a chart, things you've been doing for years. Now, uniform probability. Think about if you ever saw, kids at school that wear uniforms. They're all dressed the same. Uniform probability, each element of the sample space has the same chance of happening. It's equally likely. So let's look at some examples. If I flip a coin, I can get heads or tails. I have just as much chance of getting either one, so that's uniform. If I roll a die, just a normal die, I can get 1, 2, 3, 4, 5, or 6. Same chance of getting every number. But look here. Now, in this case, you don't have to write 4, 5, 5, 6, 6, 6. You can just write 4, 5, and 6. Those are the numbers. Now, if you wrote 4, 5, 5, 6, 6, 6, I'm not going to mark it wrong, but you don't have to. It's just asking, what are the possible outcomes? I could get a 4, a 5, or a 6. Now, it's not uniform, because I definitely have more chance of getting a 6 than a 4 or 5. I even have more chance of a 5 than a 4, because there's more of them. Here, and you can abbreviate, you don't have to write out words. You can write them if you want, but I usually just go red, yellow, blue, green. And it's uniform, because they're all the same size. Each of those is a quarter of the circle. But let's say green, and you don't have to draw this, but let's say green actually was this whole area. Well, that would be not uniform because there's a better chance of getting green than any of the other colors. Okay? Just an example. All right, how about this bag? What's in there? Well, there's red marbles and blue marbles. It's a horrible brace. Kind of backwards. Now, it's not uniform because there's 4 red, but only 2 blue. Sample space is chocolate, vanilla, and strawberry. And again, you can just abbreviate if you want, or you can write the whole word out. This is uniform because there's 1 of each type. Sample space here, boy or girl. And that would be uniform, equally likely. Okay, intuitive idea of probability. The top number is the number of successful outcomes, and the bottom number is total outcomes in the sample space. Kind of like when you take a test. How many did you get right? How many were possible? So let's think about the probability of flipping a coin. How many chances are there? Well, there's 6 numbers. My bad, I'm thinking rolling a die. Brain just went bye-bye. Let's try this again. Flipping a coin. There's 2 possibilities, heads or tails. Well, you have 1 out of 2 chance of getting a tail. That's equally likely. You also have 1 out of 2 chance of it turning up heads. Equally likely. So that means this is uniform probability. Same chance. All right, let's look at the bag. We already talked about this. There's 4 reds and 2 blues. When selecting one marble for this bag, what's the probability of picking a red? Well, that would be 4 out of 6. Now, this is interesting. You have had math teachers for years tell you always, always, always reduce. Probability in statistics is the one time you don't have to reduce. If you do, it's okay. Just do it correctly. But this is an appropriate answer. In fact, it's a little more accurate, even though they are equal, because 6 is the actual number in the bag, not 3. So, it's more likely that you'll get a red than a blue, because that's over 50%, over halfway, which would be 3 out of 6. Blue would be 2 out of 6, also known as 1 out of 3, but again, you can just leave it there. You're less likely of getting a blue than a red. Therefore, this is not uniform probability. Here's a standard deck of cards. You have the spades, clubs, diamonds, and hearts. You have ace, then 2 through 10, jack, queen, king. These are called face cards. I want to make a note of that. Face cards. Because if you look at them, those are the cards that have faces on them. Now, it says, what's the probability? And then also there are 52 in a deck. Whoops. There's also 13 of what is called a suit. 13 of each. That makes 52. Also, some things to think about. There's 26 black cards, and there's 26 red cards. So just some breakdowns of the numbers. Now, what's the probability of getting an 8? Well, you look at the 8s. You can mark this or not. There are 4 8s out of 52 cards. That's unlikely. Jack, same thing. There's 4 jacks out of 52 cards. Those could also be reduced to 1 out of 13, but you don't have to. Red, well, and that's also unlikely. Red, we just said there's 26 red out of 52. Half the deck is red. So that's equally likely. Now, face card. There are 3 face cards, 4 suits. Okay? So that's 3, 6, 9, 12, or 4, 8, 12. That's 12 out of 52. But again, since it's under half, that's going to be unlikely. Now, you roll a standard 12-sided die. Let's say you play Dungeons and Dragons. That means you're going to have 1, 2, 3, 4, and you have to write all these out. 6, 7, 8, 9, 10, 11, 12. What's the probability you roll 7? Well, there's only one of those, and there's 12 possible numbers. What about an even number? Well, let's see. 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6. That's 6 out of 12. Also known as half of the numbers. What about a multiple of 3? Well, let's see. We have 3, 6, 9, 12. That is 4 numbers out of 12. Or a third of the numbers. What's the probability you'll roll a 14? You can put 0 or 0 out of 12. Because there's no chance. That is impossible. And that's it.